Hello and welcome to today's webinar on the advanced features of the NumWorks graphing calculator. Thank you so much for joining. My name is Nick Koberstein. I'm a math teacher in residence here at NumWorks, and I'm very excited to be with everyone today to dig a little deeper into the great features that are available on the NumWorks graphing calculator. If you've watched our previous webinars, especially the introduction, this will be a great just sort of next step or follow-up to that webinar. Again, if you have any questions, you can feel free to drop those into the chat, and we'll get started here in just a moment. If you are with us already currently in live, feel free to say hello into the chat. Let us know where you are watching from, maybe what your experience has been so far with NumWorks. Also, if you have any specific questions or topics that you'd like us to cover today, feel free to drop those into the chat. If you're watching from a computer, you should be able to have a chat feature there. And I'm going to dig in here in just a moment. But I'd love to know just sort of what questions we have. There's just about a 10-second delay on that chat. So I'll get to those questions as soon as I see them. But just apologies for any delays on those. All right. So we're going to go ahead and get started. Again, if you have a specific question, feel free to drop those into the chat. But we're going to just go ahead and dig a little bit deeper into some of the applications and features on the NumWorks graphing calculator. So we're going to start with our calculation application. So I'm going to switch over to the online simulator. This is a great opportunity for you to use that online simulator if you don't have a calculator with you. You can try to follow along with me. You can also rewatch this later if you missed a step. And this online simulator is, again, offered at no additional cost. So you can just log on to numworks.com/simulator and you'll have access to our calculator. So what I'm going to do is open up the calculation application, and we're going to go ahead and start by let me click OK here. Open up that calculation application. We're going to start by looking at some matrices. So there are actually two ways that we can work with a matrix on the NumWorks graphing calculator. So the first option is going to be to open up our toolbox. So again, the toolbox on the NumWorks graphing calculator is a really helpful tool. It's going to be your best friend, honestly, on this calculator, because this toolbox key, that's the one right below OK, is going to adjust based off of the application that you're in, and also sometimes like where you are in that application. So in the calculation application, this is going to give me access to a few additional functions here, and we do have some sections here, and I'm going to look for the matrices and vectors because I want to work with some matrices here to start. So if I open up the matrices section, that gives me right away an option to start a new matrix. So I'll click OK to start my new matrix, and we're going to do a 2x4 matrix. So it shows a 2x2. These are all gray right now, so these are optional. This is going to automatically expand. I don't have to already know the dimensions and type those in. I can just go ahead and start to input those entries. So I'm going to do a 2x4. So I've got two rows with four columns. So that first row, I'm going to do a 6 and then a 2. And notice how it's automatically getting larger for me. So 1 and 0. It's going to add a fifth column, which I don't need, but again, all those gray cells are optional. Now I'm going to move down to my second row, and I'll add a 1, and then you'll notice here it did a couple things. One, it added another row for me. Those are optional, but it also made those next three cells yellow, and that's because these are going to be required in order to complete this matrix since I already started this row. So 1, 3, 5, and we'll do another 1. So that's one way to create a matrix. We can also store matrices so that we can access them later. And I'm actually going to go ahead and do that right now. I'm going to do that by using this arrow that is right below the clear button. So it's the shift option. So I'll hit shift and then the arrow key. And I'm going to store this as capital letter A. So I'm going to hit shift alpha to get my capital letters and then A. So that made this 2x4 matrix into A. And let's create another matrix. Last time we went into the toolbox to do this, but I mentioned there are two ways that we can access a matrix. The second way is to use our exponential key, or e to the x key. It's the shift option. It's that bracket. So if I hit shift bracket, that's also going to open up a new matrix for me. So I'll do another 2x4 matrix so we can do some matrix operation here in just a moment. This time I'm going to do 4 8, 0, 3. I'm going to move down to my next row, and I'll do 1, 2. Again, you'll see that the yellow means that those are required to complete it. 1, 2, 6, 1. And I'll also store this matrix. I'll store this as, I could use a lowercase letter, but I'll do capital again, so Shift Alpha B. So I've got two matrices stored here, and now we can do some matrix operation. So we can add matrices, we can use a scalar multiplication. So if I want to multiply matrix A by a scalar by 2, I could do 2 times matrix A. So I can do Shift Alpha A, and that's going to just do a scalar multiplication to that matrix. I can also do some addition and multiplication. So I could do 2 Shift Alpha A plus 4. And I could also actually just grab all of those things I've stored from the variable key. So the variable key is right next to the toolbox. If I click the variable key and I look inside my expressions, we'll see both of those matrices stored there that we can access. So B is that second 2x4 matrix. And again, I can do those matrix operations. And we can even subtract. I'm going to take advantage of the keyboard this time. One advantage of having the online simulator is you can use your keyboard to type things as well. So 2 times A minus B. Let's go ahead and create another matrix. I'm going to do a 2x2 matrix because I want to talk a little bit about matrix multiplication here. Again, if you're just joining us, we're just digging a little deeper into the NumWorks graphing calculator. We're starting with the calculation application, and I'm taking a look at some matrices. So we talked about the 2 ways to create a matrix using the toolbox or the shift option of our e to the x key or exponential key. If you have any questions, feel free to drop those in the chat. I should see those as they come in. It might be on a little bit of a delay, but feel free to drop in some questions. Just say hi as well. Would love to know where you're from, what your experience is, what questions you have, what things you'd like to see, because we can adjust this webinar based off of those questions. So I'm going to do a 2x2 matrix here. I'm going to use 2 and 1 as my first row entries. Go ahead and move down. Again, those gray cells are optional. 7 and 4, the yellow one is required. And I will store this as matrix C, alpha C. Oops, I did a lowercase. I would like that to be capitalized. We do not need to store these matrices. We could do that multiplication directly, but I just wanted to demonstrate how we can store values and then retrieve those again. So we can also do some other operations on matrices. We can do, for example, an inverse of a matrix. So that does show up actually in that matrices menu. In the toolbox, you'll see that inverse option. But you can also back out of that. You can also actually just grab a matrix, type it in manually, grab it from a stored one, and raise that to the -1 power. And that will do the inverse of that matrix. And we can double check that. We can make sure that that does what it's supposed to do. I can multiply that last matrix by matrix C, and I should expect to see that identity matrix. Yes, I do, 1, 0, 0, 1. We can also do matrix multiplication. So if I wanted to multiply matrix C by matrix A, I could do that. Now I do have to be explicit here. I do need to make sure I use that multiplication symbol because on the NumWorks graphing calculator, you're not limited to single character names for the things that you're storing. So if I had just put CA and tried to use that implicit multiplication, the calculator doesn't know what variable CA is. So we need to show that we are actually multiplying C times A. We can't do the implicit because that could be a variable. We could have defined something as CA. And so now if I have CA, would get 12. If we happen to try to do a matrix multiplication that doesn't work because those dimensions don't line up, like A times C, that's going to be undefined because we don't have the right rows and columns lining up when we did that matrix. Like I mentioned, there are several other matrix operations in the toolbox. So we can transpose a matrix, we can find the dimensions of a matrix, we could also find the determinant or the identity matrix, the inverse. And what I'd like to do actually is take a look at how we can use matrices to solve a system of equations. We of course have our equations application, which is a great way to solve equations, but maybe in your course right now you're talking about using reduced row echelon form, and that is an operation on the calculator. So let's go ahead and take a look at a problem. So I'm actually going to move back over to some notes here to show you an example of a system of equations. We've got 3 equations, 3 unknowns, and one way to solve this, of course, is to do our equation solver, but we could also use matrices to solve this system of equations. So I'm going to jump back to the calculator, and what we're going to do is we are going to first create our matrix, but we're going to grab from the toolbox, from matrices, from matrix, that reduced row echelon form. RREF, and we're going to use that operation on a matrix that represents that system. So I'll create my matrix. Again, I'm using my Shift E to the X key, and I'm going to use this matrix. This is going to represent the coefficients of that first equation. So it was 2x plus 5y plus 2z equals negative 38. Again, we only have one minus key, so just that minus 38 for negative 38. And then for the second equation, 3 and negative 2, 4, and 17. That was 3x squared minus 2y plus 4z equals 17. And that last equation was negative 6x plus 1y minus 7z equals negative 12. And if we go ahead and execute that, we're going to get our solution here. Of 25.85, negative 14. We can see that we have both the exact and the decimal approximations. We're getting both results there, that the fraction exact result as well as that decimal approximation. All right, just checking out the chat. I do see that I actually had a typo on here, which is why we got some crazy answers. If we look back at the problem I had, that was actually supposed to be a 5, not a 3. I bet that's going to clean up our answer here. There it is. So that's going to give us those cleaner set of answers here. It doesn't have to always be a clean answer, but x equals 3, y equals negative 8, z equals negative 12. So if you caught me on that, there's just a little bit of a delay. So if you throw that in the chat, I did not see that in time, but there's our cleaner answer. But again, that does demonstrate, if you were here with us last time, you saw that if we do some computations here, we do get, of course, that exact result as well as that decimal approximation. I think that's a really great feature to be able to see both of those solutions. All right, so a little bit more on the calculation application, and if there's any questions or specific things you want to see, again, just drop that into the chat. Otherwise, we'll move on to some of the other applications, but still within calculations, I want to talk a little bit about vectors. That was something that we were asked about to show. So I'm going to open up the toolbox. That is still, vectors are actually within our matrices, because to create a vector, you're just going to use a matrix, a 1-column matrix. So for a 2D vector, we'll use a 2-by-1 matrix to represent x and y. So if I want to create a new vector, what I'll do is I'll create a new matrix. We'll let this vector be 3, 4. And so again, those are optional, those gray ones. So I'm going to use this as my vector, and I'm going to store that as V. So I'm again using the keyboard because I'm using the online simulator. Those alpha characters can be found using alpha or shift alpha. So I'm going to store that as V, and we do have a few vector operations, again, within the toolbox. So if I open up that toolbox, it opens up where we left it. So we're in matrices and vectors. If I look deeper into vectors, we see we can do the dot product, we can do the cross product, and we can also find that magnitude. So let's try to find the magnitude of vector V. So I'm going to put a V there for me. So that's going to give me that magnitude. And I could also do like a dot product. So if I wanted to, I could grab that dot product, and I'm going to have 2 entries here, 2 parameters. I'll use V, my first vector, and I'll just create a new vector here within the dot product. We'll do 6, -1. Because we don't have to store those vectors beforehand, but it is a really nice tool to be able to use that variable key. And so that's going to give me my dot product. All right. last time we did talk, if you watch some of our previous ones, we talked a little bit about some trigonometry functions. Here on the keyboard, you're going to see your sine, cosine, tangent. I do want to make sure that I highlight that those inverse trig functions are just the shift option. So instead of the confusing notation of like cosine to the -1 power, which can be very confusing for students who might think that's like a reciprocal, this is like arc sine, arc cosine, arc tangent. So shift, if we did shift, for example, shift sine, that's going to be that arc sine. That's using that computer science abbreviation A sine. So for example, we could take the arc sine of the square root of 3 divided by 2. And that's going to give me that angle. We're in radians mode right now. I can see that on the top left corner. So that's going to give me the angle for which sine is root 3 over 2. That angle is pi thirds, or approximately 1.047. So those trig functions are there. I wanted to highlight that, but I also wanted to highlight that back into that toolbox. Let's back out a little bit. There is actually a trigonometry section down towards the bottom that's going to give you access to some even more advanced trig functions. So for example, your cosecant, your secant, your cotangent, and then those inverse functions are also available for you within the toolbox. And we also had, I think you might have noticed, the hyperbolic trig functions were also there. So you've got access to those as well. So those are also options for you that we did not talk about in that first intro, but I want to make sure I highlighted those. And then also, just spending some time in the toolbox. Just want to mention that there are some probability functions in here. There are some distribution functions for normal and binomial. We're going to be expanding that, but really that probability application is going to be a lot more intuitive on using. You won't have to remember a bunch of parameters or shorthand work here. So I highly recommend, if you're looking at distributions, you actually check out the inference application and the probability section within that. But combinatorics is a common topic that a lot of users might have for their classes. And so, for example, if we were trying to select how many ways we could select 5 people from a group of 12, since the order doesn't matter there, this is going to be a combination. So I can grab my combination in choose K. Again, we've got 12 people. We're choosing 5. And so we can see that number of combinations, or back in the toolbox, we've got permutations where order does matter. Like if we're arranging plants, if I had 12 plants and I wanted to choose 5 of them and arrange them in a certain way, that arrangement's going to really change the way it looks. So that order does matter. So we're going to have many more of those. That's a permutation. So those are also, again, accessible in the toolbox. If you're starting from the toolbox at the very beginning, we just went all the way down to probability and into those combinatorics. All right. The last thing I want to do in the calculation application is talk a little about some calculus. So, oops, it did not mean to exit calculation. Some people have asked about the calculus features. Again, those are also available in the toolbox. If you go into the toolbox, you'll see a calculus menu. This is going to give you access to derivatives, integrals, sums, and products. So what I can do here is I'm going to evaluate a derivative. So I'm going to grab this derivative. Oh, that's not a derivative. That's super embarrassing. Pretend I did not just call that a derivative. I'm going to grab this derivative operation here, and we're going to evaluate the derivative of x squared minus 3. So I've got my x in t key here, which I can use for my variable x squared, and I'm going to subtract 3. Whoops. Let me just start that over. Boop, boop. So let me go there again. So yes, we're going to do x squared minus 3. There it is. And we're going to evaluate this at x equals 4. So we are not a CAS calculator. That way we can be used on the ACT and a lot of state exams. So we would not be able to find like the derivative function like 2x. We can't do variable manipulation, but we can evaluate a derivative at a point. We can also evaluate integrals. For this example, I'm going to continue to do that idea of storing things. So I'm going to take this function x squared minus 3, and this time I'm going to actually go ahead and store that into a function, because I want to demonstrate what we can do with stored functions. So x squared minus 3 is exactly the function I used a moment ago, but this time what I'd like to do is just like before, store this, but I want to store this as a function. So I'm going to use my function notation, so f of x. So I'll use alpha f parentheses x. And so now I have a function. If we look at the variable key, we can actually see that if we back out and go into functions, we now have a stored function. This is actually going to work. It's going to link to our Grapher app. We'll see that stored function in just a moment. But now if I wanted to find the integral of a function, maybe from 0 to 4, and we can again type the expression x squared minus 3, but we could also grab a stored function like f of x and evaluate that derivative or that integral and get 9.333. So I'm gonna jump over to the Grapher app and talk about how those two applications can really be linked together, because I stored this function in the calculation app, but it's actually going to show up in the Grapher app. Anything in the Grapher app that I add, I could access in the calculation app, which can be really helpful for doing like evaluations of functions. So let's click that home button, head back to the main screen. If you are just joining us, welcome, hello. We're just doing a deep dive into some more advanced features of the NumWorks graphing calculator. I've got a few things I want to definitely demonstrate, but it is also an open conversation, so feel free to drop any questions or topics you'd like to see into the chat, and we should be able to talk about those as well. So I want to jump over to that Grapher application. Notice that we do have a function that is already defined, and that is because we defined this in the calculation application and stored it as f of x, so we can access that. Let's go ahead and take a look at the plot of this graph. This is just a quadratic function, been shifted down 3. I just want to highlight one more time that NumWorks does have this auto zoom feature that's going to automatically ensure that your extrema and those x-intercepts, those zeros, are going to show up in your graph. It's going to give you a nice picture of your graph, so you don't have to spend a lot of time adjusting the graph to make sure that you're looking or finding those key characteristics. Now you can, of course, adjust the graph. I want to spend a little bit more time today demonstrating how you can manually adjust this graph if you would like to. So before we do that, I do want you to notice that here towards the top, we've got auto, it's got a yellow indicator, which means it's on right now. And then there's axes. This is what we're going to select to change our axes. And notice that right now there's this not equal to symbol. And this just indicates that the scale for our axes are not equal. You'll notice that on our x-axis, we're going from about -8 to 8. But on the y-axis, we're at about -5 up to 30. So clearly those scales are not the same, which is why we see a not equal to symbol there. If we were to go into axes and click OK, our first option is to make those axes equal, because again, right now they're not. I'm going to back out for just a second. If I were to select that option, it's going to make those scales congruent by zooming out whichever scale is more zoomed in. So in this example, we're more zoomed in on the x-axis. I don't want to lose any of this information that I'm currently seeing in the y-axis. So to make these axes congruent, equal, I'm going to zoom out my x-axis. So I'm going to take that -8 to 8 and squeeze that in so that I have that same scale on the x-axis without losing any information. So I'll demonstrate that now. I'll click OK. I'll say make these equal. And you notice that it took that -8 to 8, pushed it in, so because we're really zooming out, so that now we've got those square axes here. So these axes are congruent. The scale is the same. And now you'll notice also up here that it's not on auto anymore, and that equal sign, that not equal sign, is gone. Now, alternatively, we could also manually adjust our axes in that axes menu. So we can change these values of x. So if I wanted to, for example, see my classic -10 to 10, confirm for x, and for y, I could do -10 to 10, 10. And then that view is going to give me kind of that standard graphing view, which isn't too bad here, but we do have like a lot of sort of like wasted space in this graph, a lot of white space that we could potentially see some more information with. Excellent. All right. I think I might have already mentioned last time too, if you watch that, navigate is going to also just kind of show you a little bit more of your graph. It gets rid of that top bar. As soon as I start to pan, it gets rid of that bottom bar. It just gives you a little bit more control of your graph. You can move in left, right, up, down, zoom in, zoom out using plus and minus. And you can just back out of that again if you'd like. Go back to auto to get that nice clean view. So what I want to spend some time on the graph wrap is just a few more of those calculate options. So if we go up and over to calculate, I believe we might have found either intersections or zeros last time, but I want to also just look at some of these additional features. So for example, we could find a tangent line, so the line tangent to our curve if we turn on tangent. What that's going to do is plot a point on our curve and a line tangent to that curve. So I can actually move using my left and right arrow keys. I can trace that curve. And that tangent line is going to follow along that curve. If you notice, the bottom of your screen is giving you x and y, x and f of x, as well as f prime of x. So that's the slope, that's the derivative value, and then the equation of that tangent line. So that's pretty cool. I really like that, especially if I want to kind of see what's happening to the derivative to this line as I approach different values. Similarly, if we're in a calculus class, we can navigate back up to calculate, and we can take a look at, actually just for a moment, you might have noticed this value of the derivative. Turning that on is just going to show just the derivative value for any x. Again, I can trace that curve using my left and right arrows. I can also just jump to a value. I want x to be 6, or if I wanted like -12, I'll put the 12 in first and then put the negative. Otherwise, the negative would just zoom you out. So those are also options. Let me go back to auto for 1 second. Let's talk about integrals though, because we did that on the calculation screen. But let's go to find, and let's find the integral. And this is really nice because what we're going to do is we're going to first select a lower bound. We can, of course, use our left and right arrows to select a point, our lower bound. We could also just type the value, but -4 sounds great. I think we did 0 to 4 originally, so I'll just do 0, and then I can type in 4, but I really like to actually use my right arrow at first, just to kind of see that shaded area. So there's 0 to 4. I'm going to hit enter, and I'm going to get, again, that same answer, 9.3333, and we see that this is my integral from 0 to 4, and I love the shaded part here. So that's just a nice way to kind of visualize that integral. I'm going to back out of that, get back to just my grapher app. Okay, so let's take some time and talk about some other things that we can graph. I'm going to go back to my expressions tab. There were some questions about parametric and polar curves. This has been a feature that we've had even before version 17. It was just a little tricky to find where to grab those parametric and polar curves. But now that we have these templates, these elements, if we just navigate all the way to the bottom, you've got your parametric and polar curves. Parametric curves are just going to be, you're going to kind of use a matrix here, a 1 by 2 matrix, 2 rows, 1 column, 2 by 1 matrix to define your x and your y parts of your parametric equation. So let's take a look at an example. I'm going to grab some notes here. Here is an example of a set of parametric expressions, so x of t and y of t. So take a look at those for a second. We're going to go ahead and plot those. So I'll put the calculator back on in just a moment. So here we go. So I'm going to grab my parametric template, and what I'm going to do is adjust this to my problem. So I'm going to back out the cosine of t, and I'm going to do 0.3. I'm going to use my keyboard to make it a little bit faster. 0.3 times t, and that would just be, you could just actually access that with this x and t key. Since it's parametric, it knows to use t, minus 2.5 squared plus 2, and our y of t is 1.5 sine of t plus 6. All right, so notice it does say parametric there. Now we did, if you look back at that problem, t was defined from 0 to 10, so we can do that as well. We are going to just use my right arrow to get to our 3 dots here. and we'll click OK. And that's going to give me that plot restriction. So that's going to give me the values of t for which we're plotting. So this had said 0 to 10. So instead of 0 to 2 pi, I'm going to do 0 to 10 and click confirm. And now let's go ahead and take a look at this plot. And I'm going to turn back on auto to clean that up. And here is our nice curve. We can actually trace this. This is going to trace using the values of t. So if I use my right arrow, it's going to increase the value of t. And we can see both f of t, x and y, the x and y values for that value. If we type in a value like 6, it's going to take you to t equals 6. If I did something outside of my range, it's going to be undefined, because remember this was only defined from 0 to 10. Excellent. All right, and then for polar curves, of course, we could also do a polar curve. If we go back to our expressions, we could erase this out, clear this. We could also do like a polar curve. So f of theta, I might adjust this slightly, 2 plus 3 cosine of theta. Let's see what that's going to do. So that's going to give us that polar curve, which again, we can also trace. This is going to increase that theta value. And we can see, I believe we can actually type in a theta value as well to jump to those points. So, yep, that's the grapher application. Just a few extra features that we did not talk about last time that some people had requested that we look at. Derivatives, integrals within the calculator or within the grapher, and then also graphing parametric and polar curves. If there's something specific you'd like to see or you had a question about, again, that chat is open. Feel free to drop anything into the chat and we can discuss that as well. All right, I do want to jump just for a moment over to the equations application. We did talk about the equations application in our previous webinars, but I want to mention that we're not limited to 2 equations and 2 unknowns. We are limited if we're going to do a system that they do have to be a linear equations, but we are not limited to 2 equations and 2 unknowns. We could do 3 equations, 4 equations, 5 equations. We can use x and y, but we can also use a, b, and c if that's what shows up on our problem. We could use r, s, t, apples, pears, and bananas. Like all of those would be accessible. So let's take a look at a problem. Let's go back actually to this system from before. We used our reduced row echelon form in the calculation application to solve this previously, but we can actually solve this right directly in our equation application, which is pretty cool. So I'm going to jump back to the calculator. What I'm going to do is I have my free form here, my empty. If I'm using the calculator like my handheld, I would probably grab X, Y, and Z just to save me from using my alpha buttons. And I'll just add my coefficients. So 2x plus 5y, not 3y, plus 5y plus 2z equals negative 38. Again, only one minus key, negative 38. I'm going to add another equation. Since I am using my simulator, it's a little bit easier to type on the keyboard. So I'm just going to grab that empty one and do 3x minus 2y plus 4z equals 17. And if I was using the handheld, I'd probably grab that XYZ template, but I'm just going to type in negative 6x plus y minus 7z equals negative 12. So now I've got a system here. It's 3 equations, 3 unknowns. We solved this solution before, but we can solve the system. We get that same answer, solution set, x equals 3, y equals negative 8, and z equals negative 2. I mentioned a moment ago that, we didn't have to use X, Y, and Z. We could have used like R, S, and T, but we could also use like apple. I'm pretty sure this is going to work. Banana and orange. And I'm just going to change all of those. Whoops. 3 apple, 3 times apple, minus 2 times banana, plus 4 times orange, and apple, banana, orange. Solve that system, and there we have it. Apple equals 3, banana equals negative 8, orange equals negative 2. So that's the really nice part. Earlier I mentioned about how we had to use that explicit multiplication for those matrices, C times A, and this is exactly why it's kind of a benefit that you have to do that, because it allows you to have those characters used as to define your variables. So it doesn't have to just be a single capital or a single lowercase letter. APPLE can be one variable apple. Excellent. All right, so I do want to talk a little bit about some statistics applications. We previewed this before. Anything that you guys would like to see, I'd love to grab those. Python, of course, is a great application. I really do hope to eventually have some webinars specific to Python coming very soon, and at least some handouts for you. But I just want to mention, you come with the calculator preloaded some Python scripts. You can open up those Python scripts, take a look to see how they work. You can also create your own script. At the very bottom, you can add a script. You can name that script if you'd like. I'll just call it script. And you can get in there and start to write things. Your toolbox, again, is going to be super helpful. I mentioned earlier that this toolbox is going to adjust based off of the application you're in. So here the toolbox is going to give you some different functions you can use, or different modules you can grab, and from those modules some different functions specific to them. So that can be really helpful with writing, especially on the calculator itself, some different programs. And I highly recommend, we do have some just like 1-minute tutorials on our website. If you check out numworks.com, you check out the educators section. I'll try to put that link in just a moment. There are some like 1-minute clips, tutorials specific to writing programs. So how to use like autocomplete, how to use modules, how to run a script, how to edit a script. So I highly recommend that if you're looking for some help on Python, that you check out those tutorials. And then also, I want to mention too, in the settings application, a couple things that are different with version 17. A big one here that people have asked about is just press to test. I want to highlight that. Number one, our calculator is approved for exams. It does follow the exam guidelines, calculator guidelines for those standardized exams, and for most state exams. And that does not require any changes to the calculator. You do not need to turn on press to test. Press to test is more just to give you control in your classroom. If you open up press to test, you're gonna have some features that you can disable if you'd like. So for example, if you're just not ready to have the equation solver active, you can toggle that off, and you'll just navigate to the bottom and activate your exam mode. Just note that there is a warning here. That's gonna clear all your data. So if you did want to confirm that, you'd click OK. I'll go ahead and do that here. You'll notice I've got this nice graduation cap here. That's just an indication that press to test is activated. And then, for example, since I deactivated the equations application, it now won't let me open that. Excellent. All right. So what I'd like to do then is, actually there was one more thing in the equations application that I remember someone had asked about. So let me just pull that back up. I'm just using my online simulator here. In the equations application, we just talked about having more than 2 variables and 2 unknowns, two equations and 2 unknowns. I want to talk about like what would happen, because this has shown up for some people, if you get some different sort of results here. Like what if there are no solutions? Like we've got 2 parallel lines, x plus y equals 5, x plus y equals 0. If you do have a system with no solutions, you're going to get that as your answer. So the system has no solutions, and that's because we had parallel lines here. If, on the other hand, we'll back out of this for a second, we had infinite solutions. So they are the same line, x plus y equals 5. And just to make it super obvious, we'll do 2x plus 2y equals 10. Clearly, these are the same line. And this is because we're going to have an infinite number of solutions because of that. So we do get those results pretty clear there. And then lastly, I want to take a look at like what if there's multiple solutions, like more than just 2 or 3. So for example, if we were doing like sine of x equals 0, this sine wave is going to have a value of 0 several times. So if I try to solve this, it's going to ask me for an interval for an approximate solution, because there are quite a few, and because this one we're gonna have to give it a range of values. So I'm going to do negative pi to 12 pi. So negative pi to 12 pi, and solve the equation, and that's going to give me if there's more than 10, it's going to give me the first 10 that it finds in that interval. So these are my solutions, sine of x equals 0. And since there were more than 10, it's only going to give me those first 10. So then maybe I would need to adjust from 25 to back up to 12 pi. So those are some other things that you might see, some approximate solutions you might see on the equation solver. All right, so again, I want to just open up the floor to see if there are any questions that people have that they'd like me to dig into. We've got some time left. I can definitely answer any specific questions. Feel free to drop those in. I do also want to just show here a quick survey. If you are able, I would really appreciate it. I'm going to type this into the chat here. To complete this survey, this is just going to help me continue to develop webinars or different resources, or if there's a different format that you think would be more beneficial, that would be great. But also, just if you have feedback about the calculator itself, you can drop that into the survey and let me know if you have any questions or things specific that you'd like. And then I also want to just drop in the I'm going to drop those tutorials I mentioned a second ago. Let me just grab that link for everybody, just under educators and then tutorials. And this is going to take you to all of them, including some SAT, ACT practice. That can be really helpful. Let me drop that in. But there are little tutorials for each application. So for example, if you check out the Python application, you'll be able to see that. In fact, I'll just show that real quick. That page, so we could open up Python and see a couple videos for that, and that's going to be true for each of those applications. You're going to find several videos for those applications. All right, and if there are no questions, I just want to thank you so much for coming. I'm going to take myself off of this for a second, for coming to hang out with me today and to just do a little bit of a deeper dive into some of those features. If you are a teacher at a school and you'd like to have something maybe a little more personalized, a little workshop, a little demonstration, introductory to all the applications and some features, we are currently offering a workshop format for your department, so you can reach out to me. There's my email address, nick.koberstein@numworks.com, and we can get something scheduled for you. We can dig into the different applications. We can answer the questions that your department has. If there's specific topics that you need or you just haven't had a chance to explore on your own, because I do recognize that, like any new device, there's a bit of a learning curve, and sometimes it's just a matter of having the time and the space to be able to explore it. And so my goal is just to help you do that a little more efficiently by kind of supporting you through that, guiding you through some of the applications and the features I think are really beneficial, and just giving you the space to also ask questions. So feel free to reach out. I'd love to get something scheduled. We're doing those virtually right now, and those have gone really well. So feel free to reach out. I'd love to just connect with you. Otherwise, I'll just stick around for a few more minutes to see if there's any questions or things you'd like to see. Otherwise, thank you so much for joining, and I look forward to just connecting with everybody. All right, it doesn't look like there's any questions in the chat, so I'm gonna head out. Feel free to reach out if you have any questions. And again, if you can fill out that survey, that would be greatly appreciated. Thanks so much for coming.